So hi guys, welcome to the new question. In this question, this is a question of graph, I think. So in this question, what we are doing is we have a rotating oranges question. Okay. So what type of things are here? So you have a given M cross N matrix where containing 0, 1 or 2. So what do you mean by 0 and 2? So let's go to open board and try out what I'm saying to you. So here what I'm saying to you is, like, we take a matrix like this: 2 0 1, 2 0 1 0 0, and 1 1 1, and 0 0 0 0 0 0 0, and 0 0 1 1 1 0 1 1 2 0. So this is our matrix, okay? And this is your indexes of rows, and this is your indexes of column, okay? Sorry. So what do you mean by 2? So 2 is our rotating oranges, and 1 is our fresh oranges, according to question. 2 is our rotating oranges and 1 is our fresh oranges, okay? So what you have to do? We have to just make the fresh oranges to rotating oranges. What we have to do? We have to make this fresh oranges to rotating oranges in a 1 hour. Like if we have to make a rotating oranges to fresh oranges, fresh oranges to rotating oranges, then what we have to do? We just take a one step. Like here, if we want to make this fresh oranges to rotating oranges, then we take one step, like this one step. Then we take 1 hour. And then this is going to be rotating, and then it takes his neighbor to make 1 hour. It takes 1 hour to make this orange to rotate, okay? And this will take 1 hour again to make this making this fresh orange to rotate, and this also take 1 hour to making this oranges to rotate, okay? So it takes 4 hour. So every rotating oranges taking 1 hour to make rotate. So what I'm saying to you is, like, 2 will takes 1 hour to make his neighbor. Like, it means 2 takes 1 hour to make every fresh oranges to rotate, but only neighbor, like 2 have one neighbor, 2 neighbors, 1 and 1. So it takes 1 hour to make these 2s to rotate, because this is a fresh orange. What I have to do? We have to make this rotating oranges to, so we have to make this fresh orange to rotate. And then what we are doing again, this is takes 1 hour, because this is another fresh orange, okay? So this is also take 1 hour, so 2 hour. And then this one also takes 1 hour to make rotate, and also 1 hour to make rotate, total 2 hours. So here we take 2 hours to make all rotating oranges to fresh oranges, or fresh oranges to rotating oranges. So here what we are doing is, we just clear everything so you to understand what I'm saying to you. So I'm just clear everything so you understand what I am saying to you. So what I'm saying to you, that this 2 is our rotating oranges, and we take 1 hour. To make all neighbors, like 1. So do 2 have how many neighbors? 2 have only 1 neighbors. So we take 1 hour to make all fresh oranges. What is fresh oranges? 1 is our fresh oranges, and we take 1 hour to make all fresh oranges to rotating oranges. We take 1 hour. What we have to do? We have to make all fresh oranges to rotating oranges, and we take 1 hour to make all neighbors. We take 1 hour to make all neighbors to rotate. It means fresh oranges. So these 2 takes 1 hour, and these 2 take 1 hour, and these 2 take 1 hour, and these take 1 hour, to total 4 hours to make this all neighbors to fresh oranges, 2 rotten oranges, and this 2 also takes 1 hour to make these neighbors 2 rotten oranges, 2 fresh oranges, because this is a fresh oranges, and this take also. So 2 have 2 neighbors, so it goes to 1, it goes to 1. Okay. So these 2 take 1 hour here, and these 2 take 1 hour here. So total it takes 1 hour to make all basic fresh oranges, 2 rotten oranges, and these take 1 hour again, and these take 1 hour here, and these take 1 hour here. So only 2 hours. But what we have to do, we have to just return the maximum time. So we return 4 hours is the maximum time. If any time, if we left any oranges, like if we make this one, then we doesn't reach at this place. We does not reach at this place. So we return -1 because we left 1 fresh oranges. If we left any fresh orange now, then we have to return -1 because we left 1 orange, because we can't reach here, because this is not a neighbor of any part, any rows and column. So this will remain. So we at this place we have to return -1 because this is not a neighbor of any vertex, any rows and column. So it can't be converted to fresh to rotten. Okay. So what we have to do in this approach, what we have to do in this question. So in this question what we have to do is, in this question we can apply a BFS. So how we can apply BFS? So BFS will move with a radius. BFS will move with radius. Like these two will move with radius. Let's make another sequence so you can understand easily. So we take 0. We take 2. Sorry, here we take 2. Here we take 2, 0, 1, 0, and we take just like 0. Okay, and we take here 1, 1, 1, 0, 0, 0, 0, 0, 0, and we take here 0, 0, 1, 1, 1, and we take here 0, 1, 1, 2, 0. Okay, so we have to make so this is our rotten. This is our rotten, and this is also our rotten. Okay, so we make all these fresh oranges to rotten. So this is our rotten, and what we have to do, we just call the BFS from 2. So when we call the BFS from 2, then it moves with the radius. It moves with our radius range, our neighbors. So it moves to, it goes to 1, it goes to nearest one, it goes to here and add and reached at this stage, and then we apply again at this stage BFS, and then it again goes to 1, it again goes to 1 here and here. So we apply BFS again here, and then again we apply BFS here also, then we again go here. So at this stage we take 1 hour, and these step with and these and this, and also at this step we take 1 hour. So we take total 2 hours by the BFS. So when we apply BFS on 2, then we goes at 1, we takes 1 hour, and also we take here 1 hour, and we apply this again BFS out here, and we take 1 hour. We take total 2 hours by BFS. By BFS we can count because it moves with radiusly. It moves to all existing neighbors in first time. Like 2 moves with 1, 1, 1 at every neighbors, at every possible neighbors. 2 have only 2 neighbors, so it goes to 2, and then also this one is go to 1 because it has only 1 neighbors because it is wasted. So we takes 2 hours to move all neighbors. So this by the BFS we get 2 hours, and this also this and this 2 also we also apply here BFS, and it goes to radiusly here, and it goes again here. It moves with radius now, so 2 will go here, and then we just reached at here, and it again goes to radiusly. It again goes with a radius, so it goes to here, and then again it goes to here. So we take 1 hour here, and we take 1 hour here, and we take 1 hour here, and we take 1 hour here. Total we take 4 hours. Okay, so total we take 4 hours, and after this we see that there are no any oranges to be rotten. There are no any oranges to be fresh because it also converted to 2, which is rotten. It is also converted with the 2, which is rotten. It is also converted to 2, which is rotten, and also it is converted with the 2, which is rotten. So all fresh oranges will be converted into rotten. If any chance here 1 is presented, then it will not be then all oranges is not converted to rotten, because this will save now. This will saved because any rows and column will not reach at here, because 1 is not a neighbor of any rows and column. So any BFS is not reached at here, any 2 will not reach that one, and also this 2 will not reach that one. So this will not convert into row 10. So this oranges is remained, this orange remain. So we just return -1 because all oranges cannot be converted into row 10. Okay, so what is our approach? So in this question our approach is simple. We take two while loop. We just apply one BFS. When we apply one BFS, first time BFS, then first BFS will run here. Then this while loop count how many times we apply BFS. This while loop will know how many times we apply BFS. Like here, when we apply BFS at the first time, then it will goes to our neighbors. Like 2 will go here and here. Then this is our first BFS. Okay. Then after we apply second BFS, then this condition will move here. So this outer while will know the information, will count the how many times we apply BFS. Okay, so we apply BFS at here. Okay, but this while loop will count how many times we apply BFS. So like to apply first time we apply BFS here, and then we add our neighbors, but at second time we apply again BFS at all neighbors. So we count this BFS into outer while loop. Okay, we can understand. You can understand when I'm going to code this question problem in editor. Okay, so you understand easily. Okay, so we just go to dry run so that you can understand easily. Like what? We just undo everything so that you can understand what I'm saying to you. So in this question, we just take a simple, we apply simple BFS. Okay, so first what we have to do is, okay, so we just take a queue. So we just take a queue and we apply BFS here initially. So what is the row? 0 1 2 3 4, 0 1 2 3 4. So what is the row? So initially we add these two row 10 oranges. Okay, initially we add 2 row 10 oranges. Okay, so we add 0 0 and also we add 4 3. Okay, so initially this will add in the queue. So we apply BFS at here. Okay, so we have a 2 while loop now. We have a 2 while loop. So this is our first while loop. This is a time where our first while loop will run, and 0 will removed. When 0 0 position like this 2 will remove, then it will add our neighbor 1. Okay, then it will add our neighbor 1, which is added here, which is 1 0. Okay, and then again 4 3 will remove, because this is a queue, so this will remove first. So 4 3 will remove, and it will edit our neighbors, which is here and here. So which is like this position is like 4 2, and this position is like 3 3. Okay, so these and these will removed. This is our first level. We are going to second level. So this while loop will count we are how many levels we are reached, how many time we apply BFS, how many time we apply these levels. This while loop will count, because we put 2 while loop in code. You can understand when I'm going to code it. Okay, so here what we are doing, we just remove this 1 0. When we are removing this 1 0, like this stage, at this stage when we remove this 1 0, then it will edit our neighbors. Like what is neighbors is, the neighbor of 1 0 is 1 1. Okay, so 1 1. Okay, and then it will remove, and then we are going to 4 2, 2's neighbor, this we make 2 because we visited at this stage. Now we have to make 2 because we visited at 4 2 3 3. Okay, so we make 2 because we converted this fresh orange to row 10 oranges. Okay, then this 4 2 like this will remove, and it will edit our neighbors like this and this. Okay, this and this. So this is the neighbor is like 4 1 and 3, 2. Okay, so it will remove, and then also this 3, 3 also remove, and then when this 3, 3 remove, then it will edit this neighbor, because this is wasted. Because when we remove 4, 2 now, then we make this wasted. 1, 1 and 4, 1. This 1, 1 and 4, 1. We make this 1, 1 and 4, 1 wasted when we remove 4, 2. Okay. Then also when we remove 3, 2, this 3, 2, then we make 4, 3 wasted. 4, 3 wasted, and this will remove. So this is our second level. At first level we remove this. At second level we remove this. So when we take a count 0, and we increase count to 1, and we increase count to 2 by this while loop, because we put 2 while loop. The second while loop will remove all elements, and this outer while loop will count that how many times we are apply a DFS. First level we apply this DFS, at second time we apply these DFS. Okay, then we reach that here. Okay, so here what we are doing here is, when we removing this 1, 1, when we remove this 1, 1, then what we are getting, that no neighbor is founded. When we removing this 1, 1, this here, this here, when we removing this 1, 1, when we removing this 1, 1, then we got one neighbor. What is the neighbor is 2, 1. Okay, 2, 1. Okay, but when we removing 4, 1, like this 4, 1, then here we don't get any neighbor, because this will fresh oranges will convert into rotten oranges. This fresh oranges converted into rotten oranges. Then this one will not get any fresh oranges. Okay, so it will not any count any, it will not any edit any neighbors. Okay, so it will removed. And also same here, 3, 2 will not added any neighbors. Okay, so it will also remove, because no fresh oranges are remaining, and there are no space, because 0 will not considerable. 0 and rotten oranges are not considerable, so it will not move here. Okay, so 4, 3 also remove, because at 4, 3 also no any fresh oranges. Okay, but 1, 1 added 2, 1 neighbors. Okay, this 1, 1, this 2, 1 will remaining. Okay, so this 2, 1 will convert into rotten oranges. Okay, so this 2, 1 will convert into rotten oranges, and it will remove and add its neighbor, which is 0, 2. Okay, and we increase the level. At every time we increase the level. So 3, when we remove 2, 1, then we add the level 3, and when we remove 0, 2, then we increase the level 4. Okay, so we take how many times? We apply 4 time BFS. At max we apply 4 time BFS. Maximum we apply a 4 time BFS, and we check that our fresh oranges, that our any oranges is remaining, any fresh oranges remaining, not there are no any fresh oranges presented. Every orange is converted into rotten oranges. Okay, like 0, 0, 0, 0, 0, 0, 0. So there are no any rotten oranges, there are no any fresh oranges, because fresh oranges is marking 1, so it will convert also to rotten oranges. It will also convert into rotten oranges. Okay, so all fresh oranges is converted into rotten oranges. So this is our simple VFS. So we are going to code it so you understand easily. Okay, so in the code what we have to do, so in this code, what we are doing is, so we just increase the font size so you understand easily. So okay, so this is our font size. I think it's good. So initially what we have to do, we have to just check, we have to apply just symbol check. I think we have to just, okay, so what we have to do is, so we have to just apply a simple check, like if our grid dot, if our grid equal to null, if our grid equal to null, then what we have to do, we have just written 0. Okay, so R, it can be also happen like if grid, it can be also happen like if grid dot length equal to 0, then what we have to do, we have to just return 0. Okay, and so this is our base case, like this is our edge case. It can be happen like if we get the grid is null and grid dot length is 0, like if we don't get any grid. Okay, so what we have to do again next, at the next stage, So at next stage, what we have to do, in the next stage, we just traverse the whole matrix, whole grid. Okay, so whole grid by I equal to 0 and I less than grid dot length, and then we take columns. Then we take columns and go to grid 0 dot length. Okay, so int j equal to this, here this will be 0. Okay, so here what we have to put, we have to just put a check. What check? If our grid I and j equal to 2, then we just store that place. What place? We just put a pair of rows and column. Okay, we just put a pair of rows and column. The rows and column will tell that at which stage our rotten oranges is presented. 2 will signify that this is a rotten oranges. Okay, so these row and column will added at this stage. So for this we take a queue. For this time we take a queue. Okay, for this time we take a queue, because in the DFS we apply a queue now. We make a queue. Okay, in the DFS you know that we use a queue to store the addresses, you store the positions of vertex and column and rows and column. Okay, so we just add the rows and column using new pair. So pair class is like new pair rows, I comma j. Okay, so we add new pair class. Okay, which tell that at this place our rotten oranges will presented. Okay, but else if we count our fresh oranges if I equal to 1, because we know when I equal to 1, because when here we have to apply grid I j equal to 1, then what we have to do, we have to just q dot add last new, we have to just count fresh oranges. Now we have to just count how many fresh oranges is presented in our matrix. How many fresh oranges will presented in our matrix. So we have to just take a fresh variable in fresh equal to 0, and then we have to just increase the fresh value here. So we count that in our grid how many fresh oranges will presented, how many fresh oranges will presented. What I'm saying to you is like that, like if you have 0 1 0 2 0 3 0 1 1 0, so we just count how many oranges will presented. 1, we traverse that. Okay, so you understand easily. So we just found how many oranges will presented. Okay, then we find that if all oranges, if all variables, if all at all positions fresh oranges will presented, no any rotten oranges will presented. Like if we at every place it can be happen like it at every place every rotten oranges will presented, no any fresh oranges will presented, then we have to just return 0, because every oranges will be rotten, every oranges are rotten. What is our target? Our target is to make all fresh oranges to rotten oranges. If already all fresh oranges will presented at a rotten oranges, then we have to just return 0, because fresh equal to 0 will signify that all oranges will be rotten. Okay, so at this stage we just return 0. But at the next place what we have to do, we have to apply BFS. Where apply BFS? Where we have to apply BFS at rotten oranges position, which we added at a 55 line. Okay, so we just put a while loop, and we just put a q dot size greater than 0. So we move. So this while loop will count how many times we apply a BFS at neighbors. Okay, so at the next stage what we have to do is we just take what is our size, what is our first level size. At initial stage we add all our neighbors. of all row 10 oranges. So we take a size, how many neighbors we added. Okay, okay, we take a size, and then also then at the next stage what we have to do, we have to just put again at a while loop, which is used to go to another neighbors. Okay, this while loop will remove the all neighbors and apply a BFS, and this while loop count how many times we apply all BFS. Okay, so while size is greater than 0, so at this stage what we have to do, we have to just remove our pairs. Okay, which will be added here, which will be added here. Okay, so we just remove q, we just remove the pairs which is comes from q dot remove, q dot first remove, q dot remove first. Okay, so we just remove our pairs. So what we have to do is, we have to go at all 4 directions. Okay, so we have to go at all 4 directions. So what I'm saying to you is, we have to just go, we have to just undo it everything. So we have to just make a erase here everything so that you understand easily. So we just erase everything. Okay, so what I'm saying is, at every stage we just go at all 4 directions, these 4 directions, these 4 directions, these 4 directions. So at every stage we go to 4 directions to check our neighbors. Okay, so we take a direction array, where we go 1, 0, 1, minus 1, 0, 0, 1, 0, minus 1. This will tell the positions, like y position, this will take x position, this will take minus x position, this will take minus y position. So all directions will signify that you can move in 4 directions. Okay, you understand in the previous questions, I think. So we just take a direction array. Okay, int dir equal to new int, we just take a single static 0, 1, 0, minus 1, 0, and then again also we take 0, 1, and then we take 0, 1, 0, minus 1. Okay, so this is our 2D array, this is our 2D direction array. So this direction array will signify that you can move in all 4 directions. Okay, so we just move in our 4 direction, we apply a BFS here, we apply a BFS. So what we are doing is, we apply a BFS here, and this will count how many times we apply BFS at neighbors, and this will tell that how many times we go to neighbors. This will take how many time we take we go to neighbors. Okay, and this will tell how many hours will we counted will be taking by to converting to fresh oranges to rotten oranges. Okay, so we just go here and we apply int I equal to 0 and I less than dir dot length I plus plus. So it will tell that how many directions we can go. Okay, so we just check out, we just take a int variable row equal to result dot row plus direction array dot I 0. This will go in a rows position, this will go in a horizontal position, and this will go this will go in a vertical position, and this will go in a horizontal position. This will go in a horizontal position. Okay, so at this stage what we are doing, if we check, so we go in all 4 directions. How many times, how this will say that you can go in all 4 directions, 0, 1, 2, 3, 4 length. Okay, 0, 1, 2, 3. Okay, 1, 2, 3, 4. So we move on all 4 directions. Okay, by applying this loop. Okay, so in the next step, we check that this row and column is valid. Like we can remove from our rows limit, columns length, rows length, and also it can't be negative. Okay, so we check that our row can't be negative. If our row will be negative, our column will be negative. Where when we apply a formula of 4 directions to matlab, so we apply a formula to moving in 4 directions. So when we our rows and column is going to beyond the limit, so we just check that limit. Okay, so at this step we just take row is greater than dir dot length, and column is greater than dir dot length. Okay, sorry, dot length. Okay, so what we are doing here we just check row cannot be greater than dir dot length. Sorry, dir not, they're not dir, they are grid. Okay, because we apply these all 4 directions in a grid 2D array. Okay, grid 2D array. Okay, so we just check out that row can't be 0 and column can't be less than 0, and row also can't be grid dot length, and column is also can't be greater than grid 0 dot length. Okay, so it will tell the limit of columns. And also we take no, we can't move to in row 10 oranges, and row 10 oranges will tell that at grid when we get a 2 position, when we get a value is a 2, then it will tell that it will this orange is a row 10 orange. Okay, so when we get grid row and column equal to 2, when we get row and column equal to 2, then it will tell you that you are a row 10 oranges, and this stage we can't go at this stage. Okay, so and also we check that our row and column in the grid can't be 0. Okay, because it will tell that you are not going to anywhere from that position. Okay, so it should not be equal to 0. Okay, so at these stages we just continue. We can't be added our neighbors because at these stages we can't go. Okay, so we just take a continue. Okay, then at these stages we will not added any neighbors. So if these conditions will not happen, then what we have to do, we have to add our neighbors. Okay, because we reached as neighbor at this condition, we reach at neighbors. Okay, so we just add our neighbors. So res dot add new pair, and in this new pair we just add rows and column. Okay, we just add rows and column. Okay, so after that what we have to do, we have to just many things happens, many things we forget. What type of things? We can't take count. We just take a count equal to 0. Okay, we just take a count equal to 0, and we just take a fresh oranges is -1. Okay, is -1. Okay, sorry. Okay, so we just take a count equal to 0, and we check if how many time our VFS will run, and this VFS will run how many times, we check by this count. Okay, outer value will know how many times we apply a VFS. Okay, and also after we added our neighbors, then we have to just make a visited. We just make this oranges will converted into row 10 oranges because we reached at the fresh orange initially. Okay, so we just make this rows and column to fresh oranges, 2 row 10 oranges. So we added 2 at this stage, and we have to just tell that our fresh oranges will be indent. Okay, so our fresh oranges will be decreased by 1 when we are reached at this stage, when we reached at the neighbors where the neighbors is a fresh oranges, and when add this fresh oranges, then we have to just decrease the fresh oranges value. Okay, so we decrease the fresh oranges value. So after that all condition, after after that what we have to checking is that this while loop. Okay, so after that what we have to do is if when all operations will happen, when all operation will happen, if I equal to 0, if fresh equal to 0, then what we have to do, we have to just return the count, because no one any fresh oranges will presented at here, and our target is make all the rotten oranges to fresh, all the fresh oranges to rotten oranges, and we reached at this stage. But if any fresh oranges will save, then we return -1, because fresh is greater than 0 will tell us that some oranges will remaining. Okay, some oranges will remaining. So this is our code where we just put our while loop here. This while loop is ended here, and this function ended here. Okay, so we have just applied class bracket, we forget it, then we just move at our next stage. So what we are doing here, you just understand. So initially we check our grid equal to null, and if our grid dot length equal to 0, then we just return 0, and we take a queue. Why we take a queue? Because we in BFS we add our neighbors, okay, in a queue. So we take a queue, and we take fresh equal to -1, which tell us our oranges. We doesn't know how many oranges is presented here. We just take initially fresh variable equal to -1, and we just traverse the whole matrix, whole grid, okay, and we just traverse the whole grid by this formula, okay. And if grid ij equal to 2, then we add the all pairs, okay, add the position of our rotten oranges. A rotten orange will be 2, okay, and then we just increase, and when we get 1, then we just increase the value of fresh oranges, okay. And after that we just check if our fresh equal to 0, then we return 0. Why we return 0? Because when we get all oranges is fresh, then we have to just return 0, because there are no any rotten oranges will be presented, okay. So this fresh oranges will converted all into rotten oranges, okay. When all fresh oranges will 0, then we just return 0, because we don't have to convert all fresh oranges to rotten oranges. All fresh oranges will be converted into rotten oranges, okay. So here we take int count equal to 0. Why we take count equal to 0? We just check out how many time our BFS will run, okay. So we take a direction and array to go to in all 4 directions, okay. So this will run. I hope this will run. So we just check out this will run or not, and we just go here and check out, okay. So what we getting error? I think we just get a error. So at a 76 line, pair result equal to q dot remove first, okay. So we just take q dot remove first. So what I get here is, we just check out what is the error. So it tell us that so okay, so what I'm getting error here, 1 second. Okay, I think, okay, sorry, we are not adding here pairs, okay. We have to just take, this is our pair class in the linked list, okay. So we have to tell now what type of data type we are added here, okay. Any extra error we get here, okay. Here yes, we are not decreasing the size also. I think we are not decreasing the size also, so we have to just decrease the size also. And I think anyway, you can move forward. I'm just debug the code, because you understand the concept. I think we just debug the code, because this is a whole code, okay. So I think everything is good. Okay, here we just add q add lost, okay, this is good also, okay. And the fresh is 0, and then let's return -1, okay, this is good. Okay, yes, this is another condition, that fresh equal to -1. Here fresh should be 0, because initially fresh is 0. It will represent that our all oranges is fresh. Initially all oranges is fresh, like count of fresh oranges is 0, and the count should be -1, because initially we don't have to any count, we just provide a default count. Okay, and then we have to run. So what I get 55. At 55 we get another error. So here we have to put q dot add lost, quu dot add lost. Okay, and then run. Accepted, submit. So submit. So thank you for watching the video, and also you understand everything easily. Okay.